Hi, it's Milosoft. Welcome to my channel. Before we begin, I just want to cover a couple of things regarding my videos. So recently the quality of the videos has been varied. This is because I've tried introducing background music from Slay Radio, a Commodore 64 music streaming station, just to fill some of the gaps in between the commentary. Unfortunately, when I go to process the completed video to remove some of the background noise, the music either gets removed or it ends up sounding really bizarre. So I'm having to redo some of the videos without background music, and then I'll have to process them separately for the audio portion to clean it up. Sometimes I end up having to paste different videos together, and the transitions are not always smooth. So I am working on that. I'm working to make them a little bit more presentable. Having said that, we're going to look today at Elite by Firebird. And Elite featured a device known as Lenslok. Lenslok was a copy protection mechanism, and you can see it here in this picture. And what it was a little device that you held up to the screen, and it used prisms to arrange the image into characters that you would type onto the screen. And it says here, the device could not be calibrated for large and small televisions. Some came with mismatched lens locks, and it was not used in later releases. But for the purposes of learning to crack games, we're going to be using just exactly that version. Now I have my DIR master loaded, and we're just going to take a visual look at the disk to see what's on it. You can see on track 18, sector 18, there is a disk error 23. It's a standard 35 track disk, doesn't use tracks 36 to 40. So I'm going to take this disk and I'm going to, first of all, I'm going to take the error out. And then I'm going to save the disk as the D64 version by the same name. And then we're going to take a look at the disk image itself. So we're going to load the D4 version. And we have an auto boot file. If I type in load, 8, 1, it loads elite, 8, 1. So we're just going to skip that and load elite directly. And it appears to be, it ends at 3106 as we read the bytes in reverse order. So I'm going to guess it starts somewhere around 3000, which it does. Let's break this down for you here. All right, we now have the kernel routines on the screen. So let's break it down. It loads the accumulator with 0 and stores it at FF90, which turns off error displays. It loads the accumulator with 2. I use A and accumulator interchangeably. It's the same thing. A is the accumulator. Load X with 8 and load Y with FF, which is 255. We open FFBA. That routine is file parameters. And then we open FFBD, which is file name parameters. So you'll notice that A has the file name length. X and Y points to the file name. Therefore, we know we have a 7-digit file name. And the address of the file name is going to be 30E4. Y would be the high byte. So we take a look at 30E4. And that 7-digit file name is overlay. It loads overlay. And then it opens 2,8,2. It opens another file name at 30f1, which is Lenslok. It goes to 2400, executes 2400, and then it checks to see if the carry clear flag has been set. If it has, it goes over here to 2522 for some more disk routines, otherwise it jumps to 22. Let us just take a look at the game itself, how this Lenslok functions. Okay, I cannot make heads or tails of this. I'm not supposed to, I guess. Press return, enter the letters now. I don't know what the letters are. I don't have a Lenslok device. And as you've seen in previous videos, we go Alt-M or Alt-H if you're using the Vice emulator. And we see that the program is executing 27FA. So let's take a look in and around 27FA. It's just a little delay routine. Let's hunt from 0800 to about 3000 to see if it uses the FFE4 routine. FFE4 is a routine that reads a byte from the default input. So it's defaulting to the keyboard. Checks the keyboard, compares it to 0D, which is going to be the return key. And when it's done, it sets the carry and does a return. I wonder if that's what it's calling up here. I think we found the protection already. So just to go over it quickly, once you press return, it sets the carry flag, SEC. But here, if the carry flag is clear, it goes to 308B, which is more disk drive routines. Otherwise, it jumps to 22. 22 is A673. I think that's just going to be a crash. Could it be that easy? This powerful Lenslok protection is just a matter of bypassing? Let's find out. So somewhere in here, it's going to do a clear carry. I just want to find out what the opcode is for that. Okay, we have quite a few here. 2AAD seems like a good candidate. Load 2484 and it with BF, compare 24D3. Bet you if we change this to AAB, let's try it. It crashed. We'll load it properly. Enter in letters. Nope, it appears to crash. But that's okay, because I think we've already figured out how to crack this game. And I'll break it down to you. So at 3000, we have code where it loads in a couple of different programs. It loads in overlay, Lenslok, comload, and we also see in reverse order U1:201818. Do you see it right here? If you read it backwards, U1:201818, where the disk error is. We've gone over this. We know that this is one load routine. So we're loading overlay right here. Here we're loading comload. Yep, comload. And the key routines are right here. So we know that the Lenslok routine is in the 2000 bank because that's where the program counter was. We know that the load routine takes place at 3000. And then we see here three crucial lines. First one is JSR 2400. We can surmise that that is the Lenslok routine. If branch carry clear is set, it goes down here. Otherwise, it jumps to 22. So the Lenslok routine has to set the carry clear for it to work. And the very first thing that it does when you press return, 281C, is set the clear. It doesn't clear it. So we're missing the routine that actually checks the code. But at this point, I'm going to suggest to you that we just don't need it. We don't need it at all. Here's what we're going to do. We're going to bypass the mighty Lenslok as well as the disk error. I just have to find the right file here. So what I'm doing is I'm checking 2D and 2E. 2D and 2E point to the end of file. So when you load something in on the Commodore 64, this is the start of BASIC 0801, and this is where the program ends, the end pointer. So it ends at 3106 as we read it backwards, low byte, high byte. We're going to do the infamous star routine so I can find out where the program starts and where it ends. And the star routine is just filling memory with asterisks and then analyzing to see where it gets overwritten. So 3039 is the start address. 3039 to 3106. Let's do this. We will assemble at 308. Well, we have a couple of options here. Let's just see if this is the Lenslok routine first of all. 9216. I have a feeling it is. Yeah. This is Lenslok right here. And this is checking the code. Is it good? Nope. And yes. So it's a matter of how you want your crack to be presented. You can actually call the Lenslok routine and bypass it, or you can just not have the Lenslok routine whatsoever. I think in this case we're just going to skip it entirely. So we're going to assemble at 3083, a jump JMP to 308B. Therefore, we're skipping the check, we're skipping the crash, we're just jumping right into it. And we're going to exit, we're going to save a freeze. And what did I say it was? 3039? Well, that's easy. 1, 2, 3, 4, 5. Overlay, com load. It should skip Lenslok. You can see how it's actually displaying the searching for message. The bootloader disabled that, the messages. I'm going to speed it up a bit. And it reset. Why did it reset? I already know the answer. Do you know the answer? Let's investigate. It loaded the files. It skipped over Lenslok. And now what it's doing is FFB1, which is going to be a listen command. FF93 is secondary device. FFA8, write to serial bus. I think what we're concerned about is right here, 30F8. We load Y with 12. 0C is 12 at 30F8. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And GSR FFA8, which is write a byte to the serial bus. So it is sending in reverse order because it's decrementing Y. So it's going 12, 11, 10, 9, 8 until Y hits 0. It's sending U1:201818 to check for that disk error. And that takes effect, let's see, FF96 is going to be talk command, FFA5, read byte from serial bus, and I just want to see what kind of disk error that was. It was a 23 error. Is it any coincidence that we're reading a byte from the serial bus and we're checking to see if it is a Petsky 2, because 32 is the number 2 in Petsky. And then we're reading a second value, the concurrent byte, and seeing if it's a 3. What do you think the odds are that we have an error 23 and we're checking to see if the 2 bytes via FFA5, wrong one, read a byte from serial bus, are equal to 23? I'm going to explain it to you, just for those who don't know. Oh my gosh. Something to be said for not using a real 64. Grab a byte. Is it 2? Nope. Go down here. Get bytes. Is it 3? Nope. And if not, it calls. It goes to 30DO. If it's not 30DO, calls FFAB, which sends an on talk, so it just closes the serial bus and jumps FCE2. FCE2 is a system reset. Is it equal to the 3? If it is, because it's the original disk, it goes down here and skips that entirely. FFA5 increment Y branch not equal 30D8. I'm not sure what we're doing there. Read byte from serial bus. So it's a two-step process to crack this. Step 1 is the jump to go right over Lenslok. They manufactured that lovely piece of hardware, which could be bypassed with 3 bytes. And then here, we can change this to, let's see here. Let's change right here at 30C2. Instead of a JSR to get a byte, we're going to change it to a 4C, which is a jump. And we're going to send it to 30D6. We're sending it to 30D6 because that's where it goes if you get an error 23, where it continues with the load process. And in a perfect world, this is what we would need to get a final crack. I just have to remember what the name of the file was with my short-term memory. Elite. So we're going to save Elite from 29339. Good thing I wrote it down. To 3107 in case it shaves off the last byte. And then we're going to go to our DIR master. I should point out, just for those of you who are using the Vice emulator, another way of saving it in the monitor when you go Alt-H is to just type S elite device 8 start address end address. And I think you can probably get away with at scratch elite. I think you can send a drive command just to delete the old elite first. Now, we're going to load our D64 image. We're going to delete elite. We're going to import the cracked version. We're going to remove the uppercase, replace it with lowercase, save. We'll do a hard reset. And let's give it a try. Hope for the best. And there you have it. It is successfully cracked. All right, this is Milosoft saying thank you for watching this video, and we'll see you in the next one. Bye.